Hello everyone. Today I am going to demonstrate my Kafka-based order processing system for the Big Data module. This system implements Apache Kafka with Avro serialization, real-time aggregation, real retry logic, and a dead letter queue for handling failed messages. Let's get started. First, let me show you the project architecture. This is a Spring Boot application with a Maven-based structure. We have three main components. First one is the producer, which sends order messages to Kafka. Then the consumer, which processes these orders and calculates running averages. Then the retry and dead letter queue handlers, which manage failures. All messages are serialized using Avro schema, which you can see here in the resource folder. Before we start the application, let me show you the Kafka infrastructure. I am using Docker Compose to run Zookeeper. Kafka broker, schema registry for Avro serialization, and Kafka UI for monitoring. You can see the Zookeeper service and Kafka schema registry and Kafka UI. Now we up the Docker Compose file first. As you can see, all four are created. Okay, now we check the logo. As you can see, all four services are up and healthy. Zookeeper, Kafka, schema registry, and Kafka UI. Okay, now we check the Kafka UI. This is Kafka UI, where we can monitor topics, messages, and consumers in real time. Okay, now let's start the Spring Boot application. I will run it using Maven. Okay, you can see the automatic order generator has started producing orders every 3 seconds. Let's verify that Kafka topics have been created. Let me check. Okay, now we can see the 3 Kafka topics: orders, PLQ topics, orders retry topic, and orders topic. Let me check if our Kafka topics were created successfully by using PowerShell command line. Okay, we can see that 3 topics have been created. Order topic, the main topic for new orders, order retry topic for handling temporary failures, and then order DLQ topic for the dead letter queue for permanently failed messages. Okay, now let's open Kafka UI to see real-time message flow. Here in the topic section, we can see orders topic. You can see messages are being produced continuously. The message count is increasing. 82 messages, 83, 84, like that. If you look at the actual messages, you can see that the average realization order data. Each message contains an order ID, product name, price, price and timestamp, all encoded in Avro format. In the schema registry tab, we can see our order schema has been registered with version 1. This ensures all producers and consumers use the same data structure. Let's check the consumer groups. This is the consumer groups tab. In that, we have 3 consumer groups actively processing messages. The order consumer group is processing messages from the main topic. Notice the lag is 0, which means our consumers are keeping up with the message production in real time. Total lag is 0. Okay, now let me demonstrate sending orders manually using Postman. This shows how external applications can integrate with our Kafka system through REST APIs. Okay, I'm sending a post request to create an order for a MacBook Pro. Now check. Okay, the API returns a success response, confirming that our order was sent to Kafka successfully. Now let me demonstrate sending multiple orders at once using the batch endpoint. I'm, I'm sending a request to create 20 orders for iPhone 15, price at $999.99 each. This simulates high volume order processing. Okay, the API confirms that 20 orders were sent successfully. Now we check this some Kafka UI. The message count is 450. If we send again 20 messages, the message count is 491. When you send the request 20 messages, 460 messages were. So you can see the message count has jumped significantly. The system is processing all 20 orders in parallel across the 3 partitions. One of the key features of the system is real-time aggregation. As you can see in the logs, the system is calculating running averages continuously. The system maintains both an overall running average across all orders and per product averages. For example, iPhone 15 has an average price of $999.99 across 20 orders, while the overall average across all 127 orders is $456.78. This updates in real time as new order arrive. We can also query these statics via API. Let me send a GET request to statics endpoint. Okay, the API returns the current running average, which matches what we see in the logs. Now let me show you the retry mechanism. The system is designed to handle temporary failures automatically. If you look at the logs, you will see some orders fail initially. Okay, here is a perfect example. Order 1434 failed during initial processing, so it was automatically sent to the retry topic. This is retry topic 14342 retry topic. The retry consumer picked it up, waited 2 seconds as backoff, and successfully processed it on the second attempt. This ensures no orders are lost due to temporary issues. In this demonstration run, we haven't encountered any orders that failed all retry attempts yet, which shows our retry mechanism is effective. However, the DLQ topic is ready to capture any permanently failed messages. Let me show you the DLQ topic exists. The DLQ topic is configured and ready. In a production environment, this failed message will be logged to a file and sent to an alerting system for investigation. Okay, okay. Let me verify our schema is properly registered in the schema registry. Okay, this demonstrates a production-ready Kafka system that can handle order processing at scale with fault tolerance and monitoring. The system is fully containerized with Docker, uses industry standard tools like Spring Boot and Aura, and follows best practices for distributed message processing. Thank you for watching this demonstration. The complete source code and documentation are available in my GitHub repository. Let me check this one, Kafka order system. You can see the Kafka, the README file, Kafka order processing system. In this README file, I will add all the things, pre-requirements, set of instructions, Docker compose, clean compile, monitoring tools, testing the system, how test the system, feature demonstrated, key components, and all the folder structure, and all the things in this README file. Thank you very much.